Hey friends, welcome back to the channel. This is one of the videos in the video lecture series named Calculus Hours. And today we're going to be discussing Rolle's and mean value theorem, that is the part of the applications of differentiation in the calculus. So without a further ado, let's first begin with the Rolle's theorem. So basically what Rolle's theorem says is that if you have a function f, and it obeys three conditions. If you have a function f and it obeys three conditions, and those three conditions are that that function f is continuous on a closed interval a and b, it is differentiable on the open interval a and b. Well, the third point that we're going to discuss is that this function should have the values at initial and final positions of the domain equal. So this function is gonna look something like this, where a and b, if this is the function, then a can be this and b can be this, and this is gonna return a value f of x, and this is also gonna return the same value. So if you have a function that is something like this, I mean it can be any shape, but between a and b it should be continuous, it should be differentiable, and its value at a should be equal to its value of b. Then what you can say is, then the Rolle's theorem says that now what you can state is that there is a point c between the domain a and b. There exists a point c between the domain a and b such that the gradient of the tangent at that particular point is equal to the gradient of the x-axis, and the gradient of x-axis is 0. So what Rolle's theorem says is that if there exists a function that obeys these three conditions, then there exists at least one point c between a and b such that the gradient of the tangent at that point is 0. So what it basically means is that there exists a point c such that f bar of c is equal to 0. That means that the tangent is parallel to the x-axis. So this is what the Rolle's theorem says. Now let's move on to the mean value theorem. So what does the mean value theorem say? Well, mean value theorem is much easier and less restricted. How is it less restricted? Well, we're gonna see now. So basically, consider you have a function f and it obeys, okay, now it just only has two conditions, and those two conditions are these conditions. The first two of the Rolle's theorem are the only two conditions of the mean value theorem. So the first condition is that this function is continuous on the domain a and b. It is differentiable on the open interval a and b. So if this is true for a function, then what happens is, then what the mean value theorem says is that you have a point c between a and b such that when you find the derivative at that point, then that derivative is equal to the gradient of the secant line between a and b. What this means is that, consider you have a function something like this. You have this as a and this as b. You don't need f of a to be equal to f of b necessarily to apply the means value theorem. So now what you're gonna do is, now you're gonna check if this function is continuous between a and b. So yes, this function is continuous between a and b, and this function is also differentiable between a and b. So what you're gonna say is, now the mean value theorem is valid on it, and so what I can say is there exists a point c between a and b such that the gradient of the tangent at point c is equal to the gradient of the secant line between a and b. Now what is secant line? So basically, if you have this point as a and this point as b, and you draw a line like this between a and b, now the gradient of this line is gonna be the gradient of the secant line, meaning that this line is gonna be your secant line. So what the means value theorem says is that you have a point c between a and b such that the derivative at c is equal to the gradient of the secant line between a and b. Now how do you calculate the gradient? Gradient is basically change in y over change in x. So what is your y over here? At b you have f of b, and at a you have f of a, so you're gonna write f of b minus f of a. Now what is the change in x? It is b minus a, right? So you're gonna write b minus a. So this is what the means value theorem says. It says that if you have a function such that it is continuous between a certain domain and it is differentiable between a certain domain, then you have a point C between that domain such that the derivative of the function at that point C is equal to the gradient of the secant line, that is f of b minus f of a over b minus a, where b is the maximum of the domain and a is the minimum of the domain. So these are the particular concepts. Now we're going to move on to a bunch of questions and then we're going to wind up our topic. So a quick recap, then let's move on to the questions. So the first question that I have says that you have a function f 2 plus x minus 1 and you have to check whether the Rolle's theorem is valid on the interval 0 and 2. So you need to check if this is true. The way that we're going to do that is we're going to check the first three conditions, and if those three conditions are applicable on this function, then this function obeys Rolle's theorem. So let's go on and check whether this function is continuous. Yes, this function is continuous because there are no breaks or gaps or no asymptotes. Well, this function is continuous because it returns a value on each and every single value utilized between 0 and 2. So this function is continuous. Now, is this function differentiable? Well, let's try and differentiate it. 0 plus 3 by 2 x minus 1 1 by 2. So basically what you have is that this function returns a defined value on every x that lies between the domain. So yes, this function is differentiable. Number 3, is f of 0 equal to f of 2? Is this true? So let's just calculate it. F of 0 means you're going to substitute 0 in place of x. So it's going to return 2 plus I, which is a complex number. Now let's see if f of 2 returns the same thing. F of 2 returns 2 plus 1 to the power 3 by 2, which returns 3. So no, f of a is not equal to f of b because 2 plus I is not equal to 3. Hence, you conclude that the Rolle's theorem is not valid. Now let's move on to the second question. The next question that we have is, consider a function f of x equal to 1 minus x squared over 1 plus x squared. And you have to check whether the Rolle's theorem is applicable on this function between the domain minus 1 and 1. So let's check it. Let's check the first thing. Is it continuous? So yes, it's continuous because there is no asymptote, because since x squared is a positive value and a 1 added to a positive value is a positive number, so it's never gonna be equal to 0. So there are no asymptotes. Also, there are no gaps. So this function is going to return a value on each and every single value that lies between negative 1 and 1. So if you substitute anything in place of x between negative 1 and 1, the function is going to return a value, which means this function is continuous. So yes, this function is continuous. Number 2, is this function differentiable? So let's just calculate its derivative. So you're going to apply the quotient rule over here. And now, what do we have here? Okay, so we know that this function always returns a value for each and every single value of x because the denominator can never be 0 and there are no gaps. So yes, this function is differentiable. Now part 3, f of a. Let's calculate f of negative 1. Let's calculate f of negative 1, and f of negative 1 is equal to 0, and f of 1 is also equal to 0. So f of negative 1 is equal to f of 1. So yes, Rolle's theorem is valid. Now let's apply Rolle's theorem. So what Rolle's theorem says is that you have a point C such that between negative 1 and 1 such that f bar of C is equal to 0. So let's just substitute C in place of x in the derivative of x, f of x. Now this, you're saying, is equal to 0, ladies and gentlemen. So 2c squared minus 4c equals 0. 2c, c minus 2 equals 0. So you have c equals 0 or c equals 2. Now, how are you going to choose between these two values? Well, you have a domain that lies between -1 and 1, and 2 is outside that domain. So we're going to cross out c equals 2. So our final answer is c equals 0. Now, let's move on, ladies and gentlemen, to the third question. Now what we want to do is, we want to check if you have a function f of x equals x cubed minus 3x minus 1. Now, ladies and gentlemen, what we're going to do is we're going to check if on this function, the mean value theorem is valid. The mean value theorem. Well, how are you going to check it? So, the first thing that we're going to do is check whether this function is continuous. So, well, a quick rule of thumb, every polynomial is continuous on all x. So yes, this function is a polynomial, so this function is continuous. Now, is this function differentiable? Well, let's just find out. Does this function return a value on every value of x that lies between, well, oh, I forgot to mention its domain. Its domain is -11/7 to 13/7. So, well, for every value of x that lies between this domain, this function returns a value. In fact, this function returns a value on every single x that lies between -infinity and +infinity. Hence, you always get a value of the derivative of x at every value of x. So you can say that this function is differentiable. Now, these are the only two conditions for the mean value theorem. So yes, the mean value theorem is valid. Yes, mean value theorem valid. Now, what we want to do is, we want to calculate the point C. Well, we want to apply mean value theorem, and what does mean value theorem say? Mean value theorem told us that for if the mean value theorem is valid on f of x, then there exists a point C between the domain such that its derivative is equal to the secant line between the minimum and maximum domain. So this is gonna be equal to f of 13/7 minus f of -11/7 over 13/7 minus of -11/7 makes it 24/7. We want to find out f bar of c. We found out f bar of x, that is the derivative of f of x. So we're going to substitute c in place of x. So this is going to result in 3c squared minus 3. Okay, yeah, I wrote it wrong over here. There's going to be no x over here. So what we're going to do is we're going to substitute 13/7 in place of x and f of x, that is x cubed minus 3x minus 1. Final result that we're going to get is minus 57 over 243. This gives us the same thing. So this makes this whole thing equal to 0, which means that 3c squared equals 3 and c equals ±1. So ladies and gentlemen, that's it from my side for today, and see you in the next video. Bye.